This is CPM Calculus Chapter 4, number 85. So we want to evaluate all of these by applying the Fundamental Theorem of Calculus. Okay, so we're going to evaluate these are definite integrals, and the Fundamental Theorem of Calculus basically says we take the antiderivative, right? So this is equal to the antiderivative, which means add 1 to the power. Add 1 makes it -2, divide by that power, and then have the boundaries 1 to 8 here. Right? And then we know this is just negative x to the power of -2 with the boundaries 1 to 8. What do we do next is, remember, we plug in this boundary. So we have 8 to the power of -2 minus, we have plug in this boundary, negative, or just 1 to the power of -2. Okay? So what we have to do here is, remember, power of -2 just is the same as putting it into the denominator, right, and making it positive. So this is -1 still because we have a negative. Here the two negatives become a positive, and we have plus 1, and this again goes into the denominator as a positive, right? Simplifying this, we have -1 over 64 plus 1, right? We could change 1 to be represented as 64 over 64. That's also 1. And combine the numerators, we get 63 over 64. All right? And because we have an integral, we know it represents area, so that means units squared. Box your answer, and you're done with part A. Let's go on to part B. Part B, we have here the integral. Again, these are all definite integrals of sine of x. Well, again, the Fundamental Theorem of Calculus tells us to take the antiderivative. So we know the antiderivative of sine is negative cosine of x, right? Because if we take the derivative of cosine of x, negative cosine of x, we're going to get sine. And then we go from the boundaries, sorry, not negative, but pi over 4 to pi over 2. Plug it in, so we have negative cosine of pi over 2 minus negative cosine of pi over 4. This becomes plus, right? So we have negative cosine pi over 2. Oh, I don't want to rewrite it. I want to plug it in. So I'm going to use my calculator. I have that. Cosine of pi over 2 is 0. So -0 plus cosine of pi over 4. Cosine of pi over 4 should be pi square root of 2 over 2. Yep, square root of 2 over 2. So this is equal to square root of 2 over 2 units squared. Remember, this means area, so I would always put units squared. Okay, let's go on to part C. Part C, we have this. So let's go ahead. I want to rewrite this using exponents instead of roots. So this is the integral from 4 to 9 of 3x to the power of 1/2 dx. All right. So now I'm going to take the antiderivative. That's just going to be x to the power, add 1 to 1/2, 3/2, right? We still have 3 in front, and then divide by that power. Then we go from 4 to 9. All right, the rest is just simplifying this, plugging it in. 3/2 in the denominator becomes 2/3 multiplied by 3x to the 3 over 2, still from 4 to 9, right? 3's cancel, so we have 2x to the power of 3/2 from 4 to 9. Plugging it in, we have 2 times 9 to the 3/2 power minus 2 times 4 to the 3/2 power. So you can use your calculator here if you would like, or you can just remember that 3/2 is the same as 9 to the power of 1/2 times 3, right? And 9 to the power of 1/2 is just square root of 9. That's one trick to remember. So again, I'm going to do that here, right? Square root of 9 is 3, so this is 2 times 3 cubed minus 2. Square root of 4 is 2 times 2 cubed. 3 cubed is 27 minus 2 times 2 cubed is 8. So 2 times 27 is 54. 2 times 8 is 16. Okay? And 54 minus 16 is 38. So we have 38 units squared. All right. So let's go on to part D. Part D, we have the integral of this polynomial here. So let's take the antiderivative. This is going to be 3x cubed over 3 minus 6x squared over 2 plus 2x over 1 from 0 to 2. That's the same thing. These cancel out. This becomes 3. So plug in 2. It's 2 cubed minus 3 times 2 squared plus 2 times 2 minus, and remember to put this side in parentheses always. You could even do this as well. So we're going to distribute this later. Plug in 0. That's 0 cubed minus 0, 3 times 0 squared plus 2 times 0. Well, this is all 0 anyway. So that's 2 cubed is 8 minus 3 times 4 is 12 plus 4. 8 minus 12 is negative 4 plus 4 is 0. Okay, I could say 0 unit squared or just 0. Unit squared is always good because we're doing the integral. Let's go on to part E. Part E, we have 2 times the integral, and the integral has this in the denominator, so we want to move it up first, right? Our value of x, so let's rewrite it as 2 times the integral from 1 to 3 of 3x to the power of negative 2. Okay. One shortcut I want to do is I want to bring this out front. Either that or I want to bring this inside, because this is just multiplying by a constant. I could do it either way. I'm going to bring it inside. So you can multiply the 2 in, and that just makes it 2 times 3 is 6. Right? Now I'm going to take the antiderivative, which is going to be 6x to the power of negative 1, because I'm adding 1, divide by negative 1, and go from 1 to 3. This is just negative 6, so I'm going to plug in 3. I'm going to have negative 6, 3 to the power of negative 1, minus, in parentheses, negative 6, 1 to the power of negative 1. Okay. Again, what does this mean to do? It means to put it in the denominator, so that's negative 6 over 3 to the power of positive 1. This minus cancels out with this one, so we have plus, and 1 to the power of negative 1 is also 1 over 1 to the power of positive 1, right? Simplifying this here is negative 2 plus this here is 6. Negative 2 plus 6 is 4 units squared. All right. Let's go on to part F. Part F, we have a simple integral, definite integral. So we add 1 to the power, that's 4/3. Divide by 4/3, go from negative 1 to 8. Okay. I can put this in the front. I'm going to rewrite this. That's 3/4, right? Because if I multiply by the fraction, I take the reciprocal. X to the power of 4/3 from negative 1 to 8. Plug in 8, so it's 3/4, 8 to the power of 4/3, minus, I'm put in parentheses, 3/4, negative 1 to the power of 4/3. Right? So now let's just simplify this. 3/4, well, again, I'm going to use the technique to know that I could break this up, because 8 to the power of 4/3 is the same as 8 to the power of 1/3 times 4. Okay, because this you can break up, and this, you can write like this because that's the properties of exponents. Okay, and again, I'm going to do the same thing over here with the -1. It's not really necessary because I know this is going to be +1, but let's do it. -1 to the power of 1/3 to the power of 4, right? 3/4 times, well, 8 to the power of 1/3. I know the cube root of 8 is 2, because 2 times 2 times 2 is 8. So this is times 2 to the power of 4. I'm just simplifying now. 3/4. -1 to the power of 1/3 is -1, because -1 times -1 times -1 is -1. So it's -1 to the power of 4. 3/4 times 2 times 2 is 4, times 2 is 8, times 2 is 16, minus 3/4. -1 times -1 times -1 times -1 is just +1, right? 3/4 times 16/1, these cancel out, and that's going to be 3 times 4 is 12, minus 3/4, okay? And now what we're left with, I can get a common denominator. I guess I didn't need to do this up here, right? I could just, let's undo this. Let's just multiply it across, right? So I get the denominator still 4 here, 4 times 1. 16 times 3 is, 6 times 3 is 18. 3 times 1 is 3, plus 1, that carries is 48, minus 3/4. Okay, I could have done it the other way. I'm just finding the common denominator. 48 minus 3 is 45/4. All right, you could put it in your calculator, and I think that's 11.25. 45 divided by 4, approximate answer, yeah, 11.25. So I put units squared here or here. Either one is my answer. Okay. Actually, they equal each other. I can put that even better. Okay, so now we're going to move on to part G. There's only 2 more parts. G, here's our integral. So what I see here, I'm going to make this easier for me because I could do these separately. I could go ahead and find this definite integral and add it to this definite integral. But I see something, if I factor out a 2, right, this is equal to the integral from 3 to 9, and I factor out a 2, x minus 10 is left inside, plus 2 times, actually I could bring this 2 in, so that's the integral from -2 to 3 of 2 times x minus 10 dx. Now I have the same thing here, right? Remember, whatever my curve looks like, I'm going from -2 to 3 here, and 3 to 9 here, and these are the same, so I can go ahead, since these are the same, and combine these to be from -2 to 9 of 2 times x minus 10 dx. And it's going to be the same thing as if I did them separately, so you can do them separately. Okay? And I'm going to bring this 2 out again. Doesn't really matter. Not at all. So now I'm going to take the antiderivative of this, and so that's 2 times. The antiderivative is going to be x squared over 2 minus 10x, and we have the boundaries -2 to 9. And I'm putting these braces over here because the brackets, because we're still going to multiply by 2. So same thing as parentheses. So this is 2 times, and plug in 9, so I have 9 squared over 2 minus 10 times 9. Minus, and I want another parentheses, plugging in -2. -2 squared over 2 minus 10 times -2. Okay? Close this parentheses. Now we're just simplifying this. 9 squared is 81. So 81 over 2 minus 10 times 9 is 90. Minus -2 squared is 4 over 2. -10 times -2 is +20. Right? So simplifying this, I have 281 over 2 minus 90. This right here, 4 over 2 is the same as 2, because 4 divided by 2 is 2. So that's 22, so minus 22, right? Simplify, simplify, simplify. I'm going to distribute, well, let's combine them first. I have 81 over 2, 90 and 22 can combine, so I have 112. Now I'm going to distribute that 2. The 2 cancels with this 2, and we get 2 times here. So it's 81 minus 2 times 112, right? That's 81 minus 224, and that's equal to negative 143 units squared. Okay, let me check that, just make sure I know how to add and subtract. 81 minus 224, negative 143. All right, let's go on to the last one, part H. Here we have the integral of this expression, the definite integral. So that's just going to be, let's go ahead and find the antiderivative. I'm going to add 1, so this is 9m. Adding 1, we're going to get positive 1/3, divide by 1/3, minus 2m, add 1, negative 2, divide by negative 2. And this is going to be taken from the boundary 0 to 27. Okay. Multiply by the reciprocal here to get it up in the denominator. That's 27m to the 1/3 power minus 2 over negative 2 cancel, and we get plus m to the negative 2 power from 0 to 27. Now I'm going to plug in 27. So I have 27 to the 1/3 power plus 27 to the negative 2 power minus, right? Now I'm going to plug in 0. So it's 27 times 0. Again, this is in parentheses to the 1/3 power minus m, 0 to the negative 2 power. Okay? All right. So now what do we do next? We want to go ahead and simplify. Okay, so 27 to the 1/3 power is 3, right? Let me just check that. 27, because 3 times 3 times 3. It's fun to use our calculators. 1/3 power is 3. So 27 times 3 plus, this just means 1 over 27 squared minus, here we have 0 to the 1/3 power is 0. Right, so it's 27 times 0 is just 0. This is where we have a little bit of a problem. What is 0 to the power of negative 2? Okay, why do we have, this says infinity. Okay, so 0 to the power of negative 2 is just, because we know that's the same thing as minus 1 over 0 to the power of 2, right? That's why I can't just cancel it out before. So this is going to give us 27 times 3. 27 times 3 is 81. Plus 1 over 27 squared. 27 times 27 is 729. Minus, right, and then 0, negative 1 over 0 squared. Okay, so we already have a problem here, right? This right here is a problem, right? Because 1 divided by 0 is not a number. Not a number. Okay? So what do we need to do? This, then 81 plus this is a number. This becomes plus not a number. So this overall is not a number. Okay? So this integral does not have an answer that we can compute. Okay, so let's go ahead and look at this. because the problem also says to test your solution using your integration function on your calculator. So let's do this one on our calculator. So I'm going to go to F3, go to integrate, right? The expression I want to integrate is 9m m to the power of negative 2/3 minus 2m alpha m to the power of negative 3, right? That's my expression. My variable is m. Where's m? My starting and stopping boundaries indices is so comma 0 to 27 equals, right? And I get negative infinity. So right now, let's just go ahead and say, well, negative infinity is not a number too. So let's just go ahead and say not a number, right? This is our answer. Okay? We could say no solution because our solution is not a number. Negative infinity does not work for us, even though our calculator is pretty smart and knows about it. Okay, so that's going to end for CPM Calculus Chapter 4, number 85.